In this video, I'm going to talk about the steps you need to perform to calculate the rotational inertia of the golf club for the golf club lab. Step 1. In step 1, we have the rotational inertia of a thin rod, which is 1/12 ml squared. And as you can see here, the center of mass and the pivot point P coincide. Again, remember the acronym for a thin rod. You think of a ruler as 12 inches long, 1/12 ml squared. Now, if we move the pivot point, as we were going to do in our lab, a distance d away from the center of mass, so you can see here that P and center mass do not coincide, the rotational inertia about point P is equal to the I center of mass, which we know is 1/12 ml squared, plus capital MD squared. So the mass of the ruler times how far the pivot point is away from the center of mass. Now, in step 3, we're going to add a little m to the end of the rod, which is going to be the golf club head, and it's a distance r away from the pivot point. So the total rotational inertia is the IP, which we just calculated using the parallel axis theorem, plus the little fudge factor at the end, mr squared. That's a singleton mass, a distance r away from the pivot point. And the center of mass will actually move. I didn't show it in this picture right here. It actually will move down. But for right now, it doesn't matter. When we use the energy model, it will make a difference. But for right now, it doesn't matter. Finally, to test this, step 4, we're going to use the physical pendulum equation, which is very similar to the pendulum equation we looked at before. T equals 2 pi square root of, and this is I total over mgh. Just think of the little thing of I have potential. Think I have potential, mgh is potential. And then we can hook it up to the GLX and actually get a sinusoidal wave for the period. And we can look at the period, the actual experimental value to compare. What you probably should do is go in the book and look at that variable h to see exactly what h means. So those are the 4 steps you're going to have to do to calculate and test the rotational inertia of the golf club for the golf club lab.